Okay, good morning guys. So in this session we will see how can we insert a node at the beginning, at the end and after the given data in doubly linked list, right? So first we will see insertion at the beginning in doubly linked list. Let's suppose this is a node which I want to insert at the very beginning of my doubly linked list. Let's suppose this being the PTR, right? So now guys tell me, if I want to insert this node at the beginning of this linked list, let's suppose the info part is 40, what all are the changes which is required in this case? Tell me what is the address required here, since this is the first node. Now this, if I want to insert at the beginning, so this becomes my first node. If this becomes my first node, this RPT should contain the address of next node, and this is my next node. So here what I want 100, right? And now this becomes my first node, so this becomes the LPT, and LPT of the first node should be null because there is no previous node behind this. So one change is here. This is the one first change, second change. Now any other change which you see? Yes, definitely. Now this is the second node, right? So second node LPT should contain the address of first node. So since this being your first node, so this LPT of the second node should contain the address of first node. So here it should be 400. So one change, two change, three change. Any other change which you see which is required here? Yes, one more change. Now this first pointer, it always points to the first node of a linked list. So this first point should contain the address of the first node. So here the first should contain what? 400. So how many changes total? One change, two change, three change, four change. So do you see any other change before writing the code of this? So my humble advice to you guys, like when you start writing the programs of linked list, you try to make the figure first and then try to look where all the addresses are required. So first you fill those addresses and write down the corresponding codes belonging to those nodes, and then you compile all the syntaxes corresponding to each node and each addresses, and your code finishes. So finally we basically require four changes. 100 here, null here, you want 400 here, you want 400 pointing to your first point. Fine. So any other further changes? So last node is high impact here. Fine. So this is all we require. We require only four changes. So let's write the program now. So I'm writing void insert underscore beginning. So how many pointers we require? Basically we require only just one pointer because we are trying to insert at the beginning. So there is no movement, there is no other addresses which is required. So we need only one pointer. Fine. So we require struct node star PTR. Try to allocate the memory. PTR is equal to struct node star malloc size of struct node. Fine. So this is it. And try to insert the info part. So scanf %d comma address PTR arrow info and insert 40 in the info part. Okay, so far so good guys. Now I told you that the thumb rule should be the new node which you want to create. Let's say this is the new node which you want to create, right? So try to fill the blocks which are empty. So here you want 100. So this is link part of this PTR. Fine. So in the link part you want the value 100. 100 you can directly get from the first pointer initially. So you write PTR arrow link, which is nothing but this part, and you want the value 100 here. 100 is nothing but initially the value of your first pointer is 100. So I will write first. So 100 in this case. Now done. Now you want to insert this node at the beginning, therefore the link part, this LPT of the first node should be null because there is no node behind this node. So write PTR arrow LPT because this being your LPT is equal to null. So null here. So two steps, you have completed two steps for 100 for null. The third step, what is required? You want 400 here. It means you want 400 to the LPT of the first. So what you write? You write first arrow LPT and you want 400. 400 is nothing but the address of your newly created node. That is nothing but your PTR. So here comes 400. This is also done. Now after this, three changes completed. Now you want your first pointer to pointing to the first node. Now since this is your first node, you want the first to point to 400. 400 is your PTR. So you will write first is equal to PTR, and that's it. Fine, I hope it's clear. Okay, now let's move to insertion at the last node. Okay, so I am taking the same node and I want to insert the node at the end of this doubly linked list. Insert at the end. Okay. So now think guys, what all things are important. Now you want to insert this node at the end, right? Now, if this is going to be the last node, then this is the LPT and this is the RPT. So RPT of the last node should going to be null. So this is the one change, first change which is required. Second change that is required is the LPT of the last node should contain the address of the previous node. So previous node is 300. You want 300 here. Fine. So two changes done. Then any other changes which you see here? Yes, definitely. One more change is required. So since this being initially this is the last node, right? So once you insert this at the end, this becomes the second last node. So the RPT of this node should contain the address of your last node. So here you want what? You want 400. Fine. So what all addresses are important? Think carefully. What all addresses are important? 400 is important, definitely. You will get 400 once you create this node, right? You want null, so no need to require for the null. 300 you want here. And how you will reach till 300? Because 300 is nothing but last node. So this address 300 is also important. So one address 400 is important. Second address 300 is important. Because 300 RPT you are going to change it to 400. Fine. So you basically require 2 pointers. First pointer for the creation of this node. That's your first pointer. I have created the node. Second pointer you require because you want to reach till the end. Fine. So now what I am doing firstly is I am going to move my CPT, which is initially pointing to the first node, to the last node. I want to move the CPT to the last node because I want 300, because I want to change the address RPT of 300 to the address of newly created node. So how am I going to move? So while CPT arrow RPT not equals to null, I'm going to move my pointer CPT is equal to CPT arrow RPT. Fine. I'm not explaining how it is working. It's explained it so many times. So once you write this code, so after this code, your CPT is pointing at 300. So now your CPT moves to 300. Fine. Now, I told you first thing which you have to do, guys, that you have to fill the block which are empty initially. So you want a null here. This is RPT of PTR. So make PTR arrow RPT is equal to null. So here null. Fine. Then you wanted the LPT of PTR to have the address 300. So you'll be writing PTR arrow LPT is equal to 300, and 300 is nothing but your CPT. So you write PTR arrow LPT is equal to CPT. So you're writing 300 here. Fine. So far so good. Now what you want? You want 400, and 400 is at what place you require 400? At the RPT of CPT. So you're writing CPT arrow RPT is equal to 400. 400 is your PTR. Any other changes which you see, guys? Last node isn't going to affect the first node because this is doubly linked list, not circular linked list. Fine, that's it. So I hope this is clear, guys. Thank you so much. Keep smiling. Bye.